Deep beneath our feet lies a story so incredible it has puzzled paleontologists for decades. Across continents divided by vast oceans, scientists have found identical dinosaur tracks, fossil evidence that hints at a time when the Earth looked completely different from today. Imagine standing in a rocky desert in North America, running your fingers along a massive three-toed print, only to discover that the same kind of footprint appears in Europe or Africa. How did these ancient impressions survive over 100 million years of erosion, earthquakes, and the drifting of continents? How can the same dinosaur footprints be preserved on different sides of the world? In this journey, you'll uncover how fossil discoveries like these offer more than just a glimpse of prehistoric Earth. They are windows into the story of continental drift, the breakup of Pangaea, and the mind-boggling migrations of dinosaurs that once roamed freely. We'll dig into real case studies that reveal how dinosaur tracks spanning continents became key evidence for theories once considered radical. Prepare to see how every step these creatures took left behind secrets that scientists are still decoding today. By the end, you'll understand why these fossil clues are some of the most powerful evidence we have for Earth's restless past. The fascination with dinosaur tracks. Dinosaur bones often steal the spotlight, but for many paleontologists, it's the tracks that truly bring prehistoric Earth to life. These fossilized footprints, etched into ancient riverbeds, floodplains, and beaches, offer a direct connection to the daily lives of creatures that vanished millions of years ago. While skeletons tell us how dinosaurs looked, tracks reveal how they moved, how fast they ran, and sometimes even how they interacted in herds or hunted their prey. Around the world, there are thousands of dinosaur track sites, some so vast they stretch for miles and preserve the footsteps of countless animals. One of the largest known trackways was found in Australia's Lark Quarry, often described as a prehistoric stampede frozen in time. These tracks tell the story of a dramatic chase, capturing the moment smaller dinosaurs scattered to escape a predator. Such sites prove how fossil evidence goes beyond bones and teeth, painting vivid scenes of life during the Mesozoic era. Tracks also open debates that bones alone can't settle. They challenge assumptions about species distribution, migration, and even behavior. By following these ancient pathways, paleontologists can trace routes that connect continents, adding weight to the theory that massive landmasses once formed a single supercontinent. Dinosaur tracks are not just footprints, they are stories carved in stone, connecting us to a world lost to time yet forever mapped beneath our feet. How dinosaur tracks form and survive. Long before these fossil footprints became precious clues to the mysteries of prehistoric Earth, they were simply impressions pressed into soft ground by enormous creatures moving through ancient landscapes. For a dinosaur track to survive millions of years, a perfect combination of geological circumstances had to align. A dinosaur would step into wet mud or sand, leaving behind a deep impression. Over time, layers of sediment gently covered the track, shielding it from wind and rain that could have erased it in days. As centuries passed, those layers hardened into rock, preserving every claw mark and toe detail with astonishing clarity. What's remarkable is how rare these conditions truly are. New studies show that only a tiny fraction of tracks left behind were ever fossilized. The rest were lost to erosion and the constant reshaping of Earth's surface. Certain unusual environments help these tracks survive. For example, in parts of Australia, dinosaur tracks have been found along tidal flats, where the shifting balance of wet and dry conditions helped seal the impressions quickly. In the Arctic, footprints have been discovered in permafrost regions that protect them like a natural vault. Even in deserts, where sandstorms could easily wipe them away, some tracks have remained untouched thanks to sudden floods that buried them under protective layers of silt. Famous sites like the Paleontology River in Texas or the Dampier Peninsula in Western Australia show how these perfect conditions come together. The fact that we can still see and study these footprints today is nothing short of a geological miracle. They remind us that every dinosaur track is the result of time, chance, and Earth's changing face. Each preserved print connects the ancient past to the modern world, carrying with it the secrets of a world where giants once roamed freely over landscapes now scattered across continents. Key case studies of tracks spanning continents. Among the countless discoveries that help us piece together the story of dinosaur tracks spanning continents, a few stand out for the extraordinary questions they raise about prehistoric Earth and the forces that shaped it. Take, for example, the fascinating similarities between track sites found in Australia and South Africa. On the rugged coastline of Western Australia's Dampier Peninsula, paleontologists uncovered a remarkable stretch of fossilized dinosaur footprints, some of which closely resembled tracks discovered thousands of miles away in South Africa's Karoo Basin. These impressions, believed to be around 115 million years old, show nearly identical three-toed patterns, with similar spacing and depth. Scientists have pointed out how such resemblances suggest that the same or closely related species roamed vast connected landscapes when these regions were still joined as part of the ancient supercontinent Gondwana. This idea supports the theory that dinosaurs could have migrated across what are now separate continents, leaving behind fossil evidence that still defies the barriers created by oceans. Another compelling example comes from the comparison of tracks found in North America and Europe. In the limestone quarries of Switzerland, paleontologists uncovered theropod tracks almost indistinguishable from footprints unearthed in the western United States. Both sets of tracks date back to the late Jurassic period, roughly 150 million years ago. The depth, stride length, and claw impressions match so precisely that many researchers believe they belong to closely related species, possibly even descendants of the same lineage that walked the ancient land bridges connecting what would later break apart into different continents. Such similarities strengthen the idea that continental drift, powered by plate tectonics, played a critical role in scattering these ancient pathways far and wide. Perhaps one of the most dramatic sites shedding light on this mystery is Australia's Lark Quarry dinosaur trackways. Hidden within the dry outback, this site preserves what many experts describe as the only recorded evidence of a dinosaur stampede. Here, more than 3,000 fossilized footprints reveal a moment frozen in time when smaller dinosaurs, likely ornithopods, fled across a muddy riverbank, chased by a large carnivorous theropod. What makes this site even more intriguing is that tracks of the same style and age have been found in other parts of Gondwana, particularly in Africa and South America. The suggestion is that such dramatic scenes were not isolated to a single region but may have played out across a vast connected landmass, leaving behind similar trackways on continents that would later drift apart. Radiometric dating and stratigraphic studies help place these footprints within the Mesozoic era, spanning from about 250 million to 66 million years ago. For instance, the Karoo tracks in South Africa have been dated to the early Jurassic, aligning closely with the age of matching footprints found in Australia. Likewise, the theropod tracks in Switzerland and Utah both date to the late Jurassic, reinforcing the possibility of common ancestry and migration routes that crossed now vanished land bridges. These real-world discoveries spark heated debates among paleontologists. Some experts argue that what we see as identical tracks could simply be the result of convergent evolution, where different species develop similar features to adapt to comparable environments. Others insist the footprints are too alike to dismiss as coincidence. As Dr. Anthony Romilio, a researcher who has studied the Lark quarry site extensively, noted in an interview, these trackways are more than just footprints. They are living maps of how Earth's shifting crust split ancient ecosystems apart. In recent years, advancements in technology have breathed new life into these discussions. High-resolution 3D scans and computer modeling allow scientists to compare tracks in minute detail, analyzing the depth, angle, and wear patterns that traditional casts might overlook. These techniques have confirmed subtle but critical similarities that were once invisible to the naked eye. Still, the controversy remains. Some paleontologists urge caution, reminding us that rock layers can deform over millions of years, sometimes distorting the original shapes of tracks. A print that appears identical today might have looked slightly different when the dinosaur first stepped into the mud. Yet, despite these challenges, the fossil evidence continues to build a compelling case for the theory of continental drift. Each track site, whether nestled in the Australian outback, buried beneath African plains, or hidden in European quarries, adds another piece to the puzzle of prehistoric Earth. These ancient pathways remind us that long before maps and borders divided our world, dinosaurs walked freely across vast, uninterrupted landscapes. They left behind footprints that now span continents, bridging the gap between what was and what remains. It is through these tracks, etched into stone and carried through time, that we glimpse a world both distant and connected, forever reshaping our understanding of the creatures that once dominated our planet. The science of continental drift. The story of dinosaur tracks spanning continents cannot be told without understanding the science of continental drift. Long before anyone found fossil evidence like matching dinosaur footprints, the idea that continents move seemed impossible to believe. Yet today, plate tectonics is the foundation for how we explain Earth's ever-changing face. Over 200 million years ago, all of Earth's landmasses were joined together in a single giant supercontinent called Pangaea. Imagine a world where dinosaurs could roam freely from what is now Africa into South America or from Europe into North America without any oceans in between. As Pangaea slowly began to split apart, massive slabs of Earth's crust called tectonic plates drifted away from each other, carrying entire continents along for the ride. This slow but unstoppable process scattered plants, animals, and even fossil evidence across the globe. One of the strongest pieces of evidence supporting continental drift comes from the matching patterns of fossils found on continents now separated by oceans. Fossils of the same species have been discovered in South America and Africa, in India and Antarctica, and in Europe and North America, proving that these regions were once connected. Dinosaur tracks work in the same way, acting as clear markers that the creatures that made them walked over vast connected landscapes that no longer exist in that form. Scientists now know that continents move at a pace of only a few centimeters each year, about the same rate that human fingernails grow. It may sound insignificant, but over millions of years, this slow drift adds up to entire continents colliding, splitting apart, and creating new oceans. Before the plate tectonics theory gained wide acceptance, some early scientists argued for land bridges as an explanation, suggesting that animals crossed narrow strips of land that later sank beneath the seas. However, today, the overwhelming evidence from fossil distribution, geological formations, and modern GPS data points to continental drift as the driving force behind the global spread of species and the fossil clues they left behind. When you see identical dinosaur tracks on different continents, you're not just looking at footprints frozen in time, you're looking at the undeniable proof of a planet constantly on the move. Surprising theories and controversies. While continental drift explains much about how dinosaur tracks ended up on different continents, this area of paleontology still sparks fierce debates and alternative theories. One question that often comes up is whether land bridges could have played a bigger role than we think. Long ago, some scientists believed narrow land bridges connected major landmasses even after Pangaea broke apart, acting like stepping stones for migrating dinosaurs. If such bridges existed, they might explain how identical footprints appear far from each other without requiring the continents to have been joined at the exact same time the tracks were made. Critics of this idea point out that geological evidence for these supposed bridges is often weak or missing altogether. Another controversial idea is whether dinosaurs could have migrated far greater distances than previously believed. Some researchers argue that certain species were capable of crossing harsh terrains, seasonal floodplains, and even shallow seas. If true, this would mean that the same species could have left footprints in places that were already starting to drift apart, pushing the boundaries of what we know about dinosaur endurance and adaptability. However, proving this is tricky. Tracks alone don't tell us how far an animal traveled, only where it stepped at a specific moment. This opens the door for heated debates about whether these migration theories hold any weight. Then there's the issue of fossil misidentification. Over the years, some paleontologists have warned that not all tracks that look the same truly are. Rock layers can warp over time, footprints can erode, and sometimes impressions left by different animals can appear nearly identical. Misidentifying tracks can lead to false connections between sites that may have nothing to do with each other. This has led to heated academic arguments, with some experts accusing others of overstating the case for identical tracks spanning continents. Adding to the controversy, some scientists argue that paleontologists may be so eager to find connections that they see patterns where none exist. They caution that fossil evidence, while compelling, must be examined with a critical eye. New technology like 3D scanning and digital modeling has helped settle some disputes by revealing tiny details invisible to the naked eye. But even with these tools, the question of whether some tracks truly match remains open for debate. In the end, these controversies remind us that the story of dinosaur tracks is not just about ancient footprints but about the ongoing quest to understand a world that keeps its secrets hidden in stone. The mysteries of prehistoric Earth continue to challenge what we think we know, proving that even the most solid fossil evidence can raise more questions than it answers. ChatGPT said, "What modern discoveries tell us today, the story of dinosaur tracks spanning continents is more alive than ever, thanks to modern technology that makes it possible to uncover fossil evidence once hidden deep beneath the Earth's surface." Tools like high-resolution 3D scanning have changed how paleontologists study footprints, capturing tiny details and preserving them digitally so experts around the world can examine them without ever setting foot at the dig site. Satellite imaging now helps researchers identify trackways that would be impossible to find on foot, revealing ancient pathways in remote deserts, dense forests, and even under shallow water. These advances have led to some record-breaking discoveries in recent years, including trackways stretching for miles that show entire herds moving together across prehistoric landscapes. What makes this new age of fossil hunting even more exciting is the rise of citizen scientists. Everyday people, armed with drones, GPS devices, and a sharp eye for unusual rock patterns, are finding tracks that professionals might have missed. These new sets of eyes help build an even bigger map of dinosaur footprints across continents, adding fresh evidence to support theories about continental drift and ancient migration routes. Each new find brings us closer to understanding how these tracks continue to link distant lands to one shared prehistoric past. Impact on modern science and future research. The fossil evidence left behind by dinosaur tracks spanning continents does more than just solve ancient mysteries. It plays a vital role in modern science. These ancient footprints help researchers study how climate shifts and mass extinctions shaped life on Earth. By tracing where species moved when the continents drifted, scientists gain insight into how animals adapt to changing environments. This knowledge even helps predict how today's wildlife might cope with future climate changes. Ongoing digs around the world continue to unearth new trackways, and upcoming projects promise to use even more advanced technology to scan vast areas that remain unexplored. Each new discovery adds a layer to our understanding, reminding us that Earth's story is always evolving. The tracks we find today could hold answers to questions we have yet to ask. When you look at dinosaur tracks spanning continents, you're seeing more than fossil evidence frozen in stone. These ancient footprints connect us to a world that existed long before humans walked the Earth, a world where massive creatures left their mark on a single supercontinent that later broke apart and drifted into the lands we know today. They remind us that our planet is always changing and that its mysteries are never truly solved. Now that you've learned how these clues help scientists unravel the secrets of Pangaea, continental drift, and prehistoric migration, what do you think these tracks tell us about the future of our restless Earth? Share your thoughts and theories in the comments below. We'd love to hear your take on this incredible story. And if you enjoyed this journey into the prehistoric past, make sure you subscribe to our channel for more fascinating discoveries that bring ancient worlds back to life. There's always another mystery waiting just beneath our feet.